over 2 is the same as how many degrees? 90 degrees, yep. How about pi over 4? 45 degrees. How about pi over 3? 60. And pi over 6? 30 degrees. Okay. Why am I asking these 4 in particular? I'd like you to know them, all right? And you're not going to have to memorize them because we're going to be using them more and more and more over the course of this whole unit and next unit, that I think they'll just come naturally to you. All right, you're going to see what we do with these today and why it might be important to know that 30, 60, 45, and 90 are these radians. All right? Okay, here we go into today's. Here's the goal I want today. I really don't want you to use your reference sheet if you don't have to. Okay, I want you to see that. I'll just show you as we go along here. All right, I won't give too much away. All right, so yeah, I have these circles here on the first day. I have these circles with a bunch of lines flying around. When you guys went around for me here, don't write this down. You guys did 0, 90, 180, and 270, and then went back to 360, right? Well, I wanted to convert these into radians now. Okay, I want to do it into radians. So if I start out at 0, you guys just did it for me. What's 90 in radians? Pi over 2. Anybody remember from the first day we did radians what 180 was? Well, do you remember what 360 was? 360 was 2 pi up. So I'm going to end up back at 2 pi. So what's half of 2 pi? Pi. So 180 is pi. Ooh, 270? I don't want to try to convert that. Ooh, watch. Ready? I got a little trick for you then. Ready? 0. What's really in front of this pi, even though nothing's there? Ready? 1 pi over 2. This was actually 2 pi over 2, but I reduced it. So what do you think's coming up next? 3 pi over 2, yep. So 270 is the same as 3 pi over 2. And then when I went back, ready? When I go back, I would have 4 pi over 2, but what did I just reduce that to? 2 pi, yeah. So ready? 1 pi over 2, 2 pi over 2, which reduced down to pi. 3 pi over 2, 4 pi over 2, which reduced down to 2 pi. Everyone okay now so far? Okay, let's go by 45s now. Let's go by 45s. So what? Go ahead, look back if you need to. What was 45 degrees? Pi over 4. Hey, 1 pi over 4, right? So guess what the next one's going to be? 2 pi over 4, but what can you reduce that down to? Pi over 2. With me so far here. 1 pi over 2, 2 pi over 2. Guess what this one's going to be, the next 45? 3 pi over what? Ooh, be careful. We're going by pi over 4s now, remember. So over 4. What's this one going to be? Just go with the pattern. 3 pi over 4, this will be 4 pi over 4, but reduced to what? Pi. See where that comes from now? Yeah. 4 pi over 4. 5 pi over 4. What's next? 6 pi over 4, which reduces 6 over 4. Anybody? Oh, 3 over 2. That's where all this is coming from. All right. So I got 5. I got 6. Next up, 7. And then where are we back to? 8 pi over 4, which reduces down to 2 pi. Go ahead, Megan. I'm not hating on you, Megan. I'm just hating on the fact that I did the same exact mistake third period. And that drives me nuts when I make a mistake twice and I don't learn the first time. Thanks. And now that I look at this, is this all right the way I'm doing it? Because I know pi's in the numerator don't fly with you, but Deal with it. All right, let's go by 60s now. 60s. So now these are going to go by 60s, everybody. 60s. So what's 60? Oh, don't. We did it. That's why I had you guys do the beginning exercise today. What's 60 degrees? Pi over 3. 1 pi over 3. Guess what the next one's going to be? 60 degrees. 120 would be 2 pi over 3. What's going to be after 2 pi over 3? Good talk. 3 pi over 3, which is reduced down to? What's up next? Good thing we got a shortened class today, huh? 4 pi over 3, yep. Keep going. 5 pi over 3. And then we're back at 6 pi over 3, also known as 2 pi. All right, yep, sorry, we're going to keep doing it. Going by 30s now, 30s. Pi over 6, keep going, let's roll here. 2 pi over 6, which would be pi over 3. 1 pi over 6, 2 pi over 6. This will be 3 pi over 6, which would be pi over 2. One, 2, 3. Now I'm at 4 pi over 6. You want to reduce that? That'll be 2 pi over 3. All I did was just reduce it. Keep going. 1, 2, 3, 4. What am I at now? 5 pi over 6. 5. This will be 6 pi over 6. Pi. Keep going. This will be 7 pi over 6. Keep it rolling. 8 pi over 6. 4 pi over 3. 9 pi over 6, or 3 pi over 2. Where do I keep going here? We get 10, right? 10 pi over 6. Well, what's that reduced down to? 10 over 6. 5/3 pi. 5 pi over 3. And so what are we up to? 7, 8, 9, 10, 11 pi over 6. And then I'm back at 12 pi over 6, or 2 pi again. Lucas, you want to see how this magically works? I'm going to say you have no idea. I'm not picking on you. You have no idea what 4 pi over 3 is in degrees. Off the top of your head, you have no idea. You would have to go to your reference sheet and do all the conversions, correct? Watch how quickly we can do this now. Do you know what pi over 3 is, though, from the beginning of today? 6. This right here is what? Go ahead. Is 60, right? Pi over 3 is 60 times 4. Done. 240 degrees. Did not even have to go to any reference sheet. All right. Questions? You want to do another one or no? Okay. Everyone all right? How's that? You like that trick, Ethan? Don't mock me. Here we go. We are going to go, yes, hi, how you doing? It's right behind you if you're wondering. Yeah, I got your back. Yep, literally. All right. Okay. Questions? All right. We're going to go a little bit backwards now. Remember, hey, you don't need to copy this down. Remember, I would say, I'll put it right here. Here's an angle of 100. What's its reference angle? And you guys could find the reference angle. Okay, I'm going to go backwards today, and I'm going to give you the reference angle in the quadrant. What was the original angle? Think we can pull that off? All right, I'll give you the reference angle and the quadrant. I want you to tell me what the original angle was. We all good? All right, let's do it. Okay, so my reference angle is pi over 6. Pi over 6, 30, and it's in quadrant 2. Can you draw me a reference angle of 30 degrees in quadrant 2? Oh, which axis? Y or X axis? X. Okay, good. So here's my terminal side, and the X axis should make a 30-degree angle in quadrant 2. So this angle right here is pi over 6, a 30-degree reference angle in quadrant 2. Can you help me find the original angle? Well, we're going to do both there, tough guy, but we'll first just start you youngsters out in degrees. Can you find the original angle theta for me? The reference angle was 30, meaning the rest of the angle should have been, and how are you going to find it? Want to take this, Vinny? $1.50. How'd you get it? 180 minus the reference angle, which was how many degrees? 30. Yep. So that is a 150-degree angle. Nice job. Okay, ready? No reference sheets. We can do it without it. 150 in radians. Ready? Watch the magic happen. Ethan, you want some of this? What's pi over 6? 30. What was the actual angle in degrees? So what do you multiply 30 by to get to 150? You can use your calculator for that if you need to, but what do you multiply 30 by to get to that 150? So guess what I'm going to multiply pi over 6 by? 5. What's it become? 5 pi over 6. There we go. Okay, 5 pi over 6. So again, I had a reference angle of 30, went to 150, I multiplied by 5, so that's what I multiply my radians by. All right. Nope, 1 doesn't make you great. Let's keep going. Big day today, huh, seniors? Big day. Lifetime memories made coming up here later on today. I'm sure you can't wait. What was pi over 6 again? 30. In quadrant 4 now. Quadrant 4, guys. A 30-degree angle with the x-axis in quadrant 4. So pi over 6. Can you guys find me the actual angle? Patrick, you want to take a piece of this? Hey, you're going to find the actual angle. The reference angle is pi over 6, which is 30 degrees. Ah, nice. No, is he okay? Everyone all right? Why is he not taking $1.80? He's going all the way around now. Good. 360 and doing what? Subtracting 30. So what's my actual angle theta? 330. Nice. Okay. Let's try not to. I don't want to use the reference table. Reference angle was 30. I ended up with 330. 30 times what would give me 330? 11? Everyone agree? 30 times 11 gives me 330. So what am I going to multiply pi over 6 by? 11. 11 pi over 6. You guys doing all right? You want to try? Think we should try the next one on our own, Matt, or should we try it still holding hands? We should? Okay. Go get after it. I'm not opposed. Let's see, quadrant. Oh, pi over 3. What is that one? 60-degree reference angle in quadrant 3. 60-degree reference angle. Okay. Try to stay away from that reference angle. I mean, the reference sheet. You probably want to stay away from reference angles. Anybody want to handle this one? Show off. Let's go. Show off. Reagan, you want to show off? You're looking pretty hardcore over there. What are you doing to find the angle? What are you doing to find this angle? What calculations are you doing? Okay, are you sure you want to minus 60? Because here's 180, right? And this is going 60 more. Add 60, yes. See the difference? Hey, beautiful difference between these two problems. This was in quadrant 2. I want to subtract it from 180. I want to add 180 when it's in quadrant 3 here. So it ends up being 240, all right? Reference sheet's gone away. This was, what was pi over 3 again there, kiddos? 60. 60 times what would give me 240? 4, right? So I go pi over 3 times 4 gives me 4 pi over 3. Good? Is that better, Matt? Did you pick that up? Okay, then we're all good. Moving on. No visits today, conveniently, during my class? Oh, look at you, Mr. College. Where was this one to? That's way up there. Some cold weather up there, bud. Okay. Thanks. Is that one of your top ones, or no? Not interested? Well, it's a good 4 hours, isn't it? Okay, never mind. 2.5. I thought it was 4. Maybe Potsdam 4, or is that near Plattsburgh? Okay. Good talk. All right, here we go. Hey, just trying to be invested in my students. You know, that's what they tell me in teaching school. So, all right. Quadrant 2, pi over 4. Pi over 4 is what? 45 degrees. So 45 degree. So you guys should be, look, hey, you guys should be directly in the middle here. Halfway between them. Pi over 4. What's the actual angle now? A little help here, Lucas. How are you going to find it? Well, I'm not even there yet. How do you get the actual angle in degrees? What do you want me to do? Add 45 to 90. Okay, you get away with that on this case, but you're doing it with the y-axis. I want to do it with the x-axis, though. So do 180 and what with the 45? Yes, and you end up with 135. Everyone good? 135. Now, if you want to turn it into radians real quick, 45 times what gives you 135? 3, so it's going to be 3 pi over 4. And these tricks only work with those 4 pairs of angles I gave you at the beginning of class today. Okay, if I give you something different, you're going to have to go to the reference sheet, unfortunately. All right, but these 4 are ones that are most commonly used. All right, before we get to this last part here, which we shouldn't fly by, everyone see number 1? My angle was 5 pi over 6. What was your reference angle? I gave it. It was given, so it's not. You don't have to calculate anything. The angle you found was 5 pi over 6, and then what was its reference angle? Oh, keep that in the back of your mind. 11 pi over 6. What was the reference angle? Oh, notice a pattern. If not, that's why we go to a third one. 4 pi over 3 was our angle. What was your reference angle? 3 pi over 4, reference angle of pi over 4. Do you see how quickly it's going to be now to find the reference angle, given the angle? Do we see that? Because all this are multiples of the reference angle. All right, well, let's see if you figure that out or not. Curtains, here we go. 5 pi over 6. Sketch it. Watch how quickly this is going to be to sketch now that we don't need the reference sheet. Ready for this, Brooke? Pi over 6. What in degrees? If you need to look, that's fine. 30 times 5. 150. There it is. We're sketching an angle of 150. Nobody had to pick up a darn reference sheet. Okay, again, from the beginning of class today, we knew pi over 6 was 30 times 5, 150. So we're graphing an angle of 150. Brianne, what quadrant am I in? Second quadrant. Good deal. 150. Make sure you guys get a rotation arrow for me. 5 pi over 6. And then find the reference angle in radians. Based on all those problems we just did. And let's start getting the notation. I've been sloppy with this as well. Theta with the lowercase with the subscript r, reference angle. 5 pi over 6. What's the original reference angle then? Fred? He got it. We can all get it. All right, pi over 6. Good? Not that came out wrong, but actually it came out just the way I needed it. All right. Everyone all right? Good? See how this is working now with the pi over 6, pi over 4. And again, this only works for those classic ones I gave you at the beginning of class. All right, here we go. Emma, ready? Pi over 4. She doesn't want to look. She doesn't want to look, but she can if she wants to. Okay, so I'm going graphing negative 45. What quadrant should I be in? Negative 45. Fourth quadrant. Good. Look how quickly this is going now that we know those classic radians. Just make sure your rotation arrow is going in which direction. Don't show me by your finger either. Clockwise. Ooh, you may be a little tripped up here, but don't be. What's my reference angle? Negative. What's your rule about reference angles? Correct. They got to be between 0 and 90. So you want to. So it's just 45, or in radians, pi over 4. Yep. Megan, ready? Pi over 3 was what? 60 times 4 now. 240. Done. What quadrant am I in? 240 degrees. You guys can thank me later. 240. How about the reference angle, Annika? It's 4 pi over 3, so it's just a multiple of 30. How you getting 30? It's okay, right? Hey, 4 pi over 3. I'm just multiplying 4 times pi over 3. So there's your reference angle. Sure? We sure, Patrick? Just check. No, Annika, we sure on that one? Is she, Patrick? That's what I'm asking you. Okay. Next one. You probably will have to use the calculator on this one. I don't blame you here. Pi over 4. Here we go. Emily, pi over 4 was what today? No shame in looking. We're not at the point where we've come naturally yet. They will, though. Pi over 4 was what? When you guys did at the beginning of class today, I gave you all those radians. 45, and now you're going to multiply it by 9. Go ahead. I would even it. Ooh, 405, a little bigger than 360. So what quadrants that's going to be? Will that end in, Emily? 405. I go all the way around. That gives me 360, right? Good job. Quadrant 1. Just make sure when we do this, pinwheel. Cooper, reference angle is still going to be what? Pi over 4, yep. Just a multiple of pi over 4. You guys got A, B, and C on your own right now. A, B, and C on your own. No sketches needed. Just tell me the quadrant it's in. All right, and the reference angle. Tell me the quadrant and the reference angle. Should take you about 2 minutes now. Don't use your reference sheet. You can use your calculator to multiply, obviously, but no reference sheet. Where's your girl today? It's a big day for you guys. She's missing it. I think I almost heard from most people here. Anna, what quadrant are you in for 7 pi over 6? Third quadrant, good deal. Did you get a reference angle too? Okay, let's just take a look at it. 7 pi over 6. I'm multiplying 7 times. No, you're quadrant 3. I'm just looking reference angle now. You're doing 7 times pi over 6, right? So pi over 6 is going to be your reference angle then. Okay, whatever you're multiplying that 7 or number out in front by here, that's going to be my reference angle. Good? All right, here we go. Catherine, what do you got? Quadrant what for part B? Yep. With a reference angle of 60, which would be in state, and didn't really say in radians or not, but yeah, 60 pi over 3 or 60 degrees. It didn't say how to leave your reference angle. So, and then C. Anybody want to take it? I've heard from everyone today, so I don't feel like hearing from anybody else, but I got one more question to answer. Oh, I got it. Don't worry. I got it. Quadrant 2. Reference angle pi over 4. Okay. Are we all right here? Was that too strenuous, Matt, today, or are we good? Okay, flip the page. Go get after it. You got 5 minutes here. Get after it. Flip the page. It's the same directions you guys had today. Find the actual angle in degrees and in radians.